Imagine a universe where time isn't what it seems, not a steady river flowing forward, but a flickering illusion born from the tiniest threads of reality. Welcome to the mind-bending world of quantum gravity loops and the radical idea of time emergence. At its core, this concept comes from a quest to unite two giants of physics, quantum mechanics, which governs the subatomic realm with its weird rules of probability, and general relativity, Einstein's masterpiece that describes gravity as the curvature of space-time. These two don't play nice together. Quantum mechanics thrives on uncertainty, while relativity demands a smooth, predictable cosmos. Enter loop quantum gravity, a daring theory that says space-time isn't a continuous sheet, but a grainy, woven fabric made of microscopic loops, each smaller than a billionth of a meter. These loops aren't ordinary, they're quantum objects, existing in superpositions, entangled across distances, buzzing with the probabilistic magic of the quantum world. Now, let's zoom into these loops. Picture them as the building blocks of reality, like cosmic Lego bricks, but instead of snapping together in a neat grid, they twist and knot in wild, chaotic patterns. In quantum mechanics, particles can be in multiple states at once, say, spinning up and down simultaneously, until observed. These loops do the same, flickering between possibilities, linked by entanglement, where one loop state instantly ties to another's, no matter how far apart. Loop quantum gravity suggests that space itself emerges from these tangled networks. The smoother space-time we experience, it's an average, a zoomed-out illusion, like seeing a calm ocean while missing the churning waves beneath. But here's where it gets truly wild. If space emerges this way, what about time? Most of us think time marches on, tick by tick, an arrow pointing forward. Yet, in this theory, time might not be baked into the universe, it could be a byproduct, something that pops out of the quantum chaos. Let's unpack that. In everyday life, time feels fundamental. Clocks tick, days pass, we age. But at the quantum level, things get fuzzy. Entanglement doesn't care about distance or sequence, it's timeless, connecting particles in ways that defy our usual before and after logic. In loop quantum gravity, time might emerge from how these loops evolve and interact. Imagine each loop as a tiny event, a quantum handshake, and as trillions of them tangle together, they create a pattern our brains interpret as a flow, past, present, future. It's like a movie, individual frames are static, but flip them fast enough, and you see motion. Here, the frames are quantum states, and the motion is time itself. Some physicists argue this could explain why time has a direction, why eggs break but don't unbreak. It's not a law carved in stone, it's a statistical trick, a tendency born from how these loops pile up in our universe's vast quantum tapestry. But wait, there's more to blow your mind. If time emerges this way, it might not be universal. Different regions of space-time, with different loop densities or entanglement patterns, could experience time differently. Near a black hole, where gravity warps everything, the loops might knot so tightly that time slows to a crawl, aligning with what relativity predicts, but through a quantum lens. And what about the Big Bang? In standard physics, it's the starting line, time zero. In loop quantum gravity, there might not be a beginning, just a phase where the loops were so scrambled that time, as we know it, hadn't yet emerged. This isn't just abstract math. Researchers are testing these ideas, simulating quantum loops on computers and probing the cosmic microwave background for hints of grainy space-time. The stakes are huge. If true, it means reality isn't a clockwork machine but a shimmering web of probabilities. So, where does this leave us? Picture a cosmos where space and time aren't fixed stages, but dynamic players, woven from quantum threads that dance and tangle. Time, that relentless taskmaster, might just be a story we tell ourselves, a shadow cast by the subatomic frenzy. Loop quantum gravity challenges everything, our clocks, our calendars, our very sense of being. It's not just a theory, it's a glimpse into a universe wilder than we ever imagined, where the ticking you hear isn't time itself, but the echo of quantum knots tying reality together. Next time you check your watch, ask yourself, is this moment real, or am I just caught in the weave of the quantum unknown?